First of all, I want to introduce myself. My name is Alexander Hanin. I'm founder and chief executive officer of VisionLabs. We are doing face recognition, and we are doing voice recognition for business applications. Not just for security, but our main focus, business applications. So I want to share our experience, how we use it for real commercial tasks. So some lyrics before technical information. What can we do for 1 minute? Just imagine. In most cases, nothing significant, but realize that every minute more than 100 hours of video uploaded to YouTube and more than 500,000 images uploaded to Facebook, Snapchat, and other services. So it's a huge data, and to look at manually, we need weeks. Just 1 minute data, we need weeks to look it through to find something interesting. So for these tasks, we need recognition technologies. The person, people are most frequent and important objects in visual data. So the key for understanding visual content is understand all about people and recognize them. And important question, why we use exactly face for recognition, not fingerprints, not iris. It's easier. It's fast and easy to use, even in crowded places. So it's the only way to recognize people in crowded places. You don't need to contact with human, and such applications doesn't require any special hardware. So you can use common cameras in most cases. And it's very important that you don't have to be a criminalist to measure result, because to compare output of system which can compare fingerprints, you have to be a specialist. And with faces, it's much easier. So you can refuse false positive alerts manually, for example. The right range of applications, the most common one is law enforcement, maybe security. Also, you can find it in social networks, Google Picasa, Smart TV. But the most prospective are business applications, and I'll tell you more about it. So, the market of face recognition is really huge. It will bypass $6 billion by 2080, and still major spending from government and utilities, but the share of business applications is growing rapidly now. So let's go deeper in technology. What is face recognition? Face recognition solves two tasks. The first one is verification. It's the case when we expect system to answer if the given pair of images belong to the same person or not. So you can see that the first pair is correct pair and the second one is incorrect. So we expect system to answer this. Another application is identification. In this case, when we match one picture against the database, and we expect that system will answer which IDs of images in the database corresponds to the person on the request image. So, how are we doing face recognition? To compare faces, we first detect and align face images such that corresponding face parts, eyes, nose, mouth, roughly have same location in all images. Then we extract descriptor. The most crucial part of face recognition pipeline is to convert raw image pixels into a descriptor. This descriptor should be optimized to amplify identity-specific properties of the face, while suppressing other image properties such as lighting conditions, face expressions, blur, and camera point of view. We extract this descriptor using convolutional neural network trained on very large amount of annotated face images. separate CNN descriptors are extracted for several localized face image parts and then merged into a single vector D. CNN descriptors are trained to minimize Euclidean distance between pair of faces for the same person. And at the test, the Euclidean distance between two face images provides the score of the similarity of two faces. So, how to measure success? Two faces usually declare to belong to the same person if their distance is less than some threshold t. This threshold implies detection of correct face pairs, we call this true positives, and incorrect face pairs, we call this false positives. The ideal face recognition solution have very high true positive rate and very low false positive rate. To measure performance of the system independently from particular threshold value t, we can plot all true positive rates and false positive rates for all threshold values, and then we observe receive operating characteristic curve that shows the accuracy of the system. The ideal accuracy curve should pass through the point 0, 100%. It means that system should detect all correct pairs without any false alarms. So, but it's ideal system. In real system, we have errors. We have false positive errors and false negative errors. So the equal error rate measures the deviation of the current curve and ideal system. Let's see at the real results of our system. Here you can see VisionLabs ROC curve. At the test, this recognized the faces on the database of 10,000 very difficult images from our real client. You can see that the system accuracy is almost perfect. It's over 99%. But while 99% may sound really cool, the problem is more difficult than that. Even 1% of false positives will produce thousands of false matches, false alarms at big database. Real databases are much larger than 100,000 images. So it's not good when you have every second false positive alarm. This system won't be reliable. So in real applications, we have to watch not just at the area under the curve. We should watch at the 0 point. We should go closer to the 0 because our interest is to minimize deviation the curve from the ideal point. And when you can see the scale, we scale this curve 100 times, and you can see that it's not ideal, but it's really reliable. And when we go further, when we go deeper, looking at extremely low false positive rate values, you can see that our system is not 99% accurate, but the performance of system is really cool because even with such extremely low false positive rates, we still reliable. And in real life applications, our true positive rate for fully automatic mode at such low false positive rates, we can say that it's fully automatic mode. Without no false positives, we can guarantee detection of about 60 or 70% of correct pairs. So, looking inside how our system is doing, I can just show some examples. It correctly matches images of the same persons despite very serious changes in the hairstyle, strong degradations in image quality, and poor lighting conditions. But on the other hand, the mismatches of our system corresponds to the different people, which would be recognized as different very hard even with manually operated system. These are different people, but so let's talk about how we use face recognition in real life applications and how we help our clients to save their money. The first case is a local case. You can find this problem in Russia, CIS, and such countries as Latin America, India, and some others. The case is about retail banking. You know, retail banks losing money because of loan application fraud. In 2013, they lost more than $4 billion because of this problem. And it means that average bank in Russia loses more than $10 million annually because of this problem. So what's the problem? The problem is there are a lot of bad guys who used forked identities to get multiple loans. They just substitute a picture in the ID and get more and more loans. We call the serial fraudsters, and to become a serial fraudster you have to take more than 50 loans. So such classification. So if you take more than 50 loans, you're just a young guy, the beginner. So it's a huge problem, and our ID is very simple. It's easy to substitute photo in your ID, but it's quite expensive to change your face. You know, to get a loan in Russia and many other countries, you have to go to the branch office or point of sales. It's not online at the moment. So what we are doing, how the system operates. Here is the business process of filling loan application without us, blue boxes, and white boxes, it's what we are doing. All branch offices of the banks and points of sales equipped for many years with very simple webcams for about $3 every webcam. It's just like embedded cam in a laptop. And taking a picture of the client is the common step in loan application process. So the potential borrower came to the branch office. He's sitting in front of manager and filling an application. And one of the steps is to take a picture of this guy. Banks did this step for many years before us. And the problem is nobody analyzed these photos, so it was just a picture in profile, nothing more. And what we are doing, our idea is to analyze these pictures, and first of all we want to have good pictures with good image qualities, even with such simple webcams. So that's why we automate the first process when manager putting client's information into a CRM. Our client software initializes camera, and in shadow mode it analyzes video stream to select the perfect frame, the perfect portrait. I will show it in my demo later. And then next step, every detected picture corresponds to loan application ID, and we extract the face descriptor for each portrait. So every new client can match against the list of known fraudsters. The list, but it's not only about fraudsters. You can match every new client against the list of PAP clients and the REST database, and you can use more comprehensive scoring groups for this. Finally, scoring system can analyze the results, the output of our system, the list of most similar persons to understand if one should confirm one application or refuse it. So the common situation when we use integration with, for example, SAP CRM, Microsoft CRM, SAP CRM, and another case, what about scoring system? We have the common integration with SAS systems, real-time decision manager, and for example, it can be easily integrated with Experian scoring systems. So we have several success stories in Russia and CIS when we help to cut bank losses up to 70%. It's a huge money, so bank really loves us. The next case is credit bureaus. It's the logical continuum of case one. Just imagine what if fraudster every new time visit different banks. Every bank has a local face recognition solution. It means that if this bad guy steal money from bank one, guys in managers in bank two won't recognize that because banks doesn't exchange information directly, but credit bureau do it. So credit bureau aggregates loan applications from all the market, from all banks. And last year, last autumn, the biggest credit bureau in the world, Equifax, selected VisionLabs face recognition engine to provide interbank fraud detection service. So the full system, which automates taking the pictures, which can recognize fraudsters and regular clients in-house in the bank. And the final layer is the cloud for interbank blacklist. Actually, credit bureau feel good and they don't suffer from fraudsters, but they want to increase revenue and lifetime value and to get competitive advantages from the other credit bureaus. So that's their motivation. So how it works? They try to use different types of biometry, but nobody wants to go to the bank if bank asks you to get your fingers. It's not convenient way, but face it's a common way. Everybody feels okay if you are taking the picture. So and it's the most cheapest way to identify your clients. So then, credit bureau aggregates this data, facial descriptors, portraits, and client IDs without any personal data. And then it can detect anomalies such like same face but different IDs. So while Bank 1 and Bank 2, from my example, use the system, in-house system and cloud system, if a bad guy from Bank 1 first time came to the Bank 2, they can say, oh, yeah, I know you, you steal money from our neighbors. So it's how it works. Next very important and interesting case, and it's not just local case, it's global, it's offline retail. So retailers want to measure audience, they want to measure conversion and increase lifetime value and average check from each customer. So for these purposes, they launch loyalty programs, but operating offline in retail shops, point of sales, they don't know actually who are their clients. They cannot recognize regular clients, they cannot count how often they came back, who are they, and so on. And it's very easy to recognize your customer while you're operating online. You can use IP address and many other features, but it's a huge gap between online and offline. So our mission in this case is to close this gap and allow retailers to recognize their customers, maybe online customers, when they came offline to their shop. So, and once again, the secret sauce is face recognition. So our system use already installed cameras on the entries, on the other points of sales. So every entering client, we can remember his face, and then we can have such statistics to recognize him once he return to this shop next time. Also, we can annotate this spatial data with CRM profile to aggregate history of purchases, his personal preferences, and loyalty data. So it's very important statistics, and it really helps businesses to operate more efficiently. They can detect anomalies. For example, if you have 10 shops in your chain, and one of the shops has extremely low conversion rate, so it means that you have to fire the head of the shop and do something. So to summarize my short speech, I just want to mention once again that the market of facial recognition is really huge, and we will just begin. The technology becomes really useful for real-life applications with very low false positive rate last year, and it's officially detected in public tests. So the technology is really enough for most commercial applications, and VisionLabs proved it in real-life business cases. So we save money for our clients. So I will miss this slide, and I have some appendix. It's more technical slides than the previous ones, but I think it's important to know how we operate inside. I mentioned CNN, that we use convolutional neural networks, and using CNN is a real revolution. We feel it because at this plot you can see that the blue line is state-of-the-art trained on huge amount visual data method. It's not secret, it's our previous method. We are going to make it public and open source. We used dense features and aggregated them into a feature vector, and then matched these vectors using support vector machine. So it's very simple, but in most cases it's enough. So we are going to make it public for students, for developers, and so on. But while we switch to the CNN without any training, it performs a little bit better performance than very cool state-of-the-art previous method. And when we train CNN on bigger and bigger amounts of real data, we pushed the limit very high. So it's really cool. And looking more deeper in technology, I said that we use separate CNN descriptors. We extract separate CNN descriptors for different face parts. So we use something like face pyramid, full face, quarters of the face, and so on and so on. So at the moment we use 10 convolutional neural networks with 120 million parameters each. So totally we have more than 1 billion parameters for the face recognition. And it's the plot with a description of how important the complexity of the model. So we can use just one CNN. It will acquire 10 times less hardware resources, but perform not bad recognition rate compared to previous state-of-the-art methods. But it's better to use 8 to 10 CNNs. So this way we can provide the maximal recognition rate. Oh, thank you.